So, surface area of pyramids. Now, with a pyramid, most of you know what a pyramid looks like. Okay? Hopefully all of you know what it looks like, but I know most of you do. Okay? The thing we have to be aware of today, we're talking about regular pyramids, meaning that the base, that should probably be a solid line, is a regular shape. So like if this was a rectangular pyramid, the base is a square. Does that make sense? It's a regular figure. So if it's a pentagonal pyramid, it's a regular pentagon, meaning all the sides are the same length. If it's a triangular pyramid, that means the base is an equilateral triangle. Okay? If your shape is regular, that means all the triangles making up the lateral faces, or going up the sides, are the same, correct? Okay.
Yeah.
I should have drawn that a little bit bigger. Let me do that. I'll probably mess it up now that I'm trying to draw bigger. Are you drawing or talking, Carson? Okay. The challenging part of this, and this, I guess this isn't challenging, but we are going to have two different heights here. You're going to have your height of your pyramid, which is going to be on the inside. It's going to go from the middle of the base straight up to the vertex, the very tip. Okay. We are also going to have what we call slant height. Your slant height is on the side or is on one of your lateral faces, and it goes from the vertex to the middle of that side. Does everybody see what I'm looking at there? Hey, your height goes up on the inside. Your slant height goes down the side. So this right here in blue would be your slant height, which is going to be symbolized by a cursive letter L. We are going to have to find the slant height. You cannot find the surface area without doing that. Because when I find the surface area of a pyramid, I need to find the area of the base and add in the area of each side, right? You guys follow what I'm saying? Now the sides are what shape though? Triangles. How do you find the area of a triangle? Base times height. Okay? So you have to know this slant height because it's the height of your triangles. Everybody follow that? Okay. So let's just take a second here. We are going to take basically the same diagram, and we're going to be given some information, and we are going to find the slant height. They tell us that the vertical height of this pyramid is 12 centimeters. They tell me that this length is 10. We want to know what is the slant height. Okay. Now, if that whole base of my pyramid right here is 10, how far is it from here to here? Has to be half of that, right? Everybody understand why? Because this is a regular pyramid, so the base is a square, and that is dead in the center, right? So from the center to the side has to be 5. What do I have formed here in red? More specifically, a right triangle. Now, the catch is, the height and this part are inside your pyramid. The slant height is outside your pyramid, right? But is it still a right triangle? Yes. So I have a right triangle, 5, 12. How do I find the third side? Pythagorean theorem. You should already actually know the third side of this, but let's go ahead and work out the Pythagorean theorem. 5 squared plus 12 squared, right? Yeah, it's going to be 13. 5 squared is 25 plus 144 equals c squared. 25 and 144, 169. 13 equals c. So my slant height is 13. I think I said centimeters. Okay. You're going to have to be able to pick out right triangles and use Pythagorean theorem to solve for that missing side. Okay. Is everybody okay on this diagram? I'm going to back up here in a second. Can I go backwards? Okay. Sometimes, that's not what I wanted to do. I don't really know what just happened. I think I added a page maybe. Yep. Okay, sometimes they're going to tell you that this is 10, and then they're going to give you this edge length instead. They're going to tell you that this edge is 11. I don't know. Okay? I need to find the slant height again. Now how am I going to do it? Well, it's a regular pyramid, so the sides all have to be the same. So that means this is 10, right? So this has to be 5. So now what do I have? I have another right triangle. Is any of this right triangle on the inside? No, but it's still a right triangle, right? Okay. We're not going to take the time to solve this out, but the point I'm getting at is you're going to have to be able to solve and find different right triangles in these pyramids to be able to find your slant height when they don't give it to you. Okay, sometimes it might have something to do with something on the inside, sometimes it might not. Okay, but you have to find right triangles to solve for your slant height.
What's slant height?
Hmm?
So, when it's inside the triangle, it's always the hypotenuse.
When it's inside the triangle, it's always the hypotenuse. When it's outside the triangle, it's always the long leg. Alright, your theorem for today. Surface area of a regular pyramid. Surface area equals the area of the base plus 1/2 the perimeter times slant height. And I guess you don't have to put a parenthesis in this case, but if you want to label all those letters again, feel free to do that. Capital B is the area of the base. Capital P is of the base, perimeter of the base, and then L we just learned is slant height. Okay. Now again, to find the surface area of a regular pyramid, basically I'm finding the area of the base, and I'm finding the area of the lateral faces, which are triangles, and adding them together, right? They give me the surface area, if you want to think about it differently. This formula, it does the same thing. Why is there only one B when all our other theorems from the last couple of days had two B? Because there's only one base, okay? Where's the 1/2 come from?
Because you're only doing half the time.
Close, Royal.
Find the area of the triangle is
Yeah, because if I found the area of my triangles, it's 1/2 base times height, right? Perimeter includes all the bases of my triangles, right? And then slant height would be the height of all my triangles. Okay, so am I still doing the same thing we talked about a second ago? Yeah, you're still finding the area of the base, and you're adding in the area of the lateral faces. Okay, we're just condensing it so it's not quite as long. Bless you. Okay. So let's they're going to jump you right into a more difficult one. It's not super difficult, actually, because they give you so much information. But they give you a hexagonal pyramid right away. Okay, so do your best to get this hexagonal pyramid drawn on your paper. No, we're just doing pyramids today. You guys need a second to keep drawing? Pyramids? Yeah, they're challenging. All right. And then inside of that pyramid, they have... Don't make me hungry. It's only third period. Over there talking about enchiladas. We have that. And then they tell us that the base is 6 meters. And the slant height is 8 meters. So what I have going on here, this red triangle is actually laying down on the base inside the pyramid. Does everybody follow that? Hey, maybe you can see it in your book a little bit better. And then this blue is coming down the lateral face. It's a slant height. Okay, so it's coming down a lateral face. And then 6 is the length of each side of my hexagon. Okay. So when I plug this in and try to find the surface area of this, I start, surface area is, what's the first thing? Area of the base, which in this case happens to be a hexagon, right? So we have to go through the process of finding the area of our hexagon. Nice thing about this, they gave us that the base is 6, right? And then they drew this triangle in here showing us that the apothem is 3 square roots of 3. So do we actually have to solve for anything extra here? No. Be aware, just because they're doing it on this problem doesn't mean you're not going to ever have to. You should be able to find the area of a hexagon by this point. Okay, you might have to find the central angle, divide it by 2 and get that angle, use your trig functions, whatever you have to do to come up with that apothem. Okay, but you have to have this apothem to be able to find the area of this, right? Okay. This case, they give it to you, so it's actually fairly easy. How do I find the area of this triangle? Okay, I'm going to do 1/2 base times height. Okay. What's half of 6? What's 3 times 3 square roots of 3? 9 square roots of 3. So that's the area of my triangle, right? And then I multiply that by 6. So the area of my base is actually 54 square roots of 3. Okay, so I took care of the area of my base, and then I have plus what? 1/2. Why 36, Jacob? Because we're finding the perimeter. So Jacob, notice that we're finding the perimeter of the hexagon. Each side is 6. There's 6 sides. So the perimeter is 36 times the slant height, which in this case is 8. Okay, you can't simplify this at all, so this stays as 54 square roots of 3 plus, what's half of 36? What's 18 times 8? 144. I'm going to rewrite this so my radical's last, because that's actually the more proper way to write that. Okay, so I have 144 plus 54 square roots of 3. Taylor Stokes, what's my label? Does everybody agree with her that it should be squared? Because we're finding area, surface area. Okay. If you want to put that as a decimal, feel free. Okay. I would rather you not. I would rather leave that as a reduced radical, because that's what we're going to have to use next year. And remember, that actually got you some bonus on your tests on the last test. Okay. All right, I got one more for you. It's not actually in the book. We're just going to make this one up. It's just going to be a regular rectangular pyramid. My pyramids are getting better. Let's see yours.
Okay.
Yeah, yours might be better than mine. Okay. What we're doing here, let's say we have ten. Let's say this is 8. I'm not going to put labels on here. Let's just talk units. I want to find the surface area. Okay. Carly, get us started.
From the middle of the base to the side is 4.
Okay, so that has to be 4, right? Because this is a square. So that has to be 4. Now, if it were a pentagon, or a hexagon, or a whatever, you could use your central angle, your trig functions, and hopefully come up with that apothem also. Can we do that? We should be able to at this point. But since it's a square, Carly just shortened it up and found that that's 4. So am I going to be able to find my slant height fairly easy? Yeah, because my slant height is here, and I have this right triangle, right? Okay, so how am I going to set that up, Carson? Okay, so total here I have. So C equals square root of 116. Can I break that down, Royal? Jacob? 4. Because 4 goes into 100 and it goes into 16, so it has to go into 116. So it's 4, square root of 4 and the square root of 29. Square root of 4 is, so I have 2 square roots of 29 as my slant height, right? Do I have enough information to now go ahead and find surface area? Yeah, because I can find the area of this square very easy. How do I do that, Vincent? Find the area of the base for me. Which is? Plus, what comes next? In your equation. Area of the base plus, in our theorem we just did, one half, right? And then perimeter of the base, which is what? What shape's my base here, Vincent? So how do I find the perimeter? Okay, they add 2. 32. Last part is slant height, which we found to be 2 square roots of 29. Now I can just start simplifying this. 64 plus, what's half of 32? What's 16 times 2 square roots of 29?
32 square root of 29.
How'd you go? I just curious how you went backwards there. Did you divide? Did you square root it? Just make sure you're multiplying here, right? Okay. Half of 32 is 16, right? 16 times 2 square roots of 29 is 32 square roots of 29. Okay. Label. In this case, it's just units squared because I didn't put anything else up there. Okay. So, might you have to find slant height before you can find your actual surface area? Yeah. And maybe you don't do it first like Carly did. Maybe you start setting this up, get to here, and you're like, oh shoot, I don't have my slant height. And then you find it. That's fine. She just knew she was going to need it, so she found it right away. Okay, however you want to do that is just fine. I do want you to be aware, on number 19, they give you this edge length. Okay, so maybe this is 13. So just be aware that your right triangle is here now, right? Everybody see what I'm talking about?
Yep.
Okay, just be aware of what they give you. Because on 19, they don't give you the slant height. They give you the edge length. So you're going to have to use Pythagorean theorem on the outside there to come up with that slant height. Questions? Okay. It is going to take a little bit of work, so we don't have a ton of problems. Okay, but I think you guys are more than capable of doing this. We're just combining a bunch of things that we've already done.